Boom. Really got to adjust this camera. Let's try it. Let's get it up here. That's a little better. All right, y'all doing 42? Give me a glass of water. How much time we got? Well, mastery prep day. What time we get out?
9:02, right? I think it's 9:02. So 10 minutes.
All right, so baseball is hit almost straight up into the air with a speed of 25 meters per second. So we got a baseball, okay, with an initial velocity, right? And we're going to want to know how high it goes, how long it's in the air, and what factors make this an estimate. Let's go ahead and talk about that before we get into the math. So this is an estimate because this assumes there's no air resistance, right? Okay, so if you went outside and hit a baseball like this, it's not going to actually go as high as we're about to calculate. Okay, the more aerodynamic something is, the closer it would be to what this equation says. If you include air resistance in this, you've got to do calculus. Okay, there is a way to do it. It's what I mean, real physics. It includes air resistance because you have to, right? If you're trying to engineer something, you can't just ignore the fact that there's air resistance and friction. So you've got to deal with it. The problem is that the air resistance changes as the speed changes. So you've got multiple changing variables at the same time, which is called differential equations, which is the fourth calculus class you take in college, and the one that I made a C in because my professor was on probation for failing too many people. I benefited from that. Back to the trade-offs conversation earlier, right? So what's the trade-off to having the hardest math professor in the university? Is he had failed so many people that he had to pass. I had to pass, but I wasn't gonna make better than a C. Like you're trading that off, right? Like, no, I'm not gonna fail, but I'm not gonna make a B, an A or a B. Like I knew that going into it. But hey, just trying to get the credit, you know.
So is this question like assuming that the baseball's on the ground and just starts floating up at 25 meters per second? Because if you hit it, it's going to be like a few feet off the ground.
Okay. We can always declare our zero, though. We're going to declare our origin to be where it hit the bat. It's a good question, though. We assume often that the ground has to be the origin, it doesn't have to be. So it doesn't say how high it goes from the ground, it just says how high does it go. So we can declare where we want to measure that from.
But then how long it's in the air falling in?
Well,
yeah.
Oh.
Yeah.
Okay. Okay. All right. I was thinking how long it took it just to get to that maximum height. But we're going to come back to the ground. Okay. So it's easy to figure out how far it comes back to the bat, but we got to know how far the bat is above the ground and how far it takes it to the ground. It's going to take a little bit far longer, right? So from bat up is, I said, that's 2 seconds. Then it takes 2 seconds to come back to the bat. Okay, but if we're going all the way to the ground, it's going to take a little bit longer than 2 seconds to get all the way back to the ground.
Yeah.
So the question is not overly clear about that. let's alter it here a little bit and just say how long does it take it to get to that maximum height? That we don't have to worry about. And let that maximum height be above the bath. They could have written this a little clearer, I agree. All right. So we have a V0 of positive 25. And when I'm doing these questions with an object's going to go up, down, and maybe up, down, and back and up, or whatever, I'm going to be kind of obvious about the pluses and the minuses, right? I'm going to put the plus just to remind myself that's what's going up, right? Okay. So we know it's got an acceleration of minus 9.8. Okay. So we want to find its vertical displacement and the time it took to get there. Well, when it gets to the highest point, we need to remember that it'll have a final velocity, v, of 0. So it'll stop when it gets there. All right, so about that equation. Or that equation. Does it matter? We don't have time. We don't have time. That's right, we don't have time. That's that equation. Yep. All right, so we got to go with the third. We don't have time. All right, so.
Good morning, teachers and students. Please pardon this interruption for a brief announcement. Just like to thank everyone for the smooth testing cycle yesterday morning and a great event last night with Meet the Golden Eagles and the reopening of our stadium. Just a few words today about Mastery Prep. We are on Mastery Prep schedule. Students should report to the exact place that they tested. That is their first rotation spot for Mastery Prep. The goal today, seniors, all seniors will report to the lunchroom where you will be given instructions on your weekly routine. 9th, 10th, and 11th graders will report to your Mastery Prep location to review your ACT practice test number 1 results from yesterday. Teachers, I sent a couple of items via email to guide you on the importance of the ACT and to remind everyone of the aspects of reviewing scores that are available to us in an email. So utilize that and work through it together. 7th and 8th grade will report to your Mastery Prep location just like yesterday. Some will need to finish their testing. So today will be about reviewing how we did and get settled into that routine. We are seeing market improvements in our ACT scores collectively and some very much individually. So please continue to take advantage of this program. It is making a difference. Thank you.
I got an answer for that first part.
I got 31.9%.
One thing I want to point out right quick before the bell rings, you got to keep up with your negative signs right here. There's a lot of them, okay? So there's a negative and the G's negative, so you got to have both those negatives to cancel. You won't get a positive displacement, which means somehow you hit the ball up, but it ended up going down. That would make sense, right? And if you ever get negative time, you did something wrong, okay? So if you get negative displacement, it might be the right answer. It depends on the situation. Negative time is not a thing, okay? So we never hit a ball and it went back to yesterday. That didn't happen, okay? So if you get negative time, that means you've got signs messed up somewhere. So what's this answer real quick before we go? We got like 2 minutes here.
31.9.
31.9, okay? What we got right here?
I got 2.55.
2.55 seconds. That sounds reasonable.
I got that in a different way.
Okay, there are more than one way to skin these cats.
Because I worked it out, when we did it like that, I worked it out with, just dividing the acceleration. Or I guess initial velocity by acceleration. And I just put that
So you
into,
got the time first.
yeah, I got the
Yeah.
time first, and then I put that.
That's fine.
That works.
All right, check something before we walk out of here. If you look at, slideshow, today we were on slide number 19. If you go to that, slide number 20 has some practice problems for, it's got textbook, workbook, and there's a free fall quiz on AP Classroom now. You can take that, please. And then there's a couple of videos I'd like for you to watch before tomorrow. Tomorrow we'll do a little bit more of this, and we're gonna do what we call some graphical analysis, which is, we did a little bit of that the other day, so it's not overly new. Basically learning how to look at a graph and get a visual idea of how the object's actually moving and vice versa. Okay, so we take a description of motion, sketch a graph, look at a graph, come up with a visual idea of how something's moving about. All right, and that'll be tomorrow. So do those things before we get back in here, please. And we'll see.
So if you had like a really massive fall, would it be like slightly wrong